In this section, we're going to be doing more solving of equations. And let me start with one that I'm going to do in great detail. And I'll do them in detail, at least the first few of them, and then the latter ones I'll try to do in more brief form. So let's start off with this equation. Solve 3x minus 8 equals 10. Now, before I solve it, I want you to think of something here. Let's set that one to the side for a minute. Suppose I gave you this thing to do. If I ask you to do 3 times 6 minus 8, what you would do first is you would do the multiplication first, and then you would do the subtraction second. So the first would be multiplication, and the second would be that subtraction. So the way you would do this, 3 times 6 minus 8, you would do the 3 times 6 first and get 18, bring down the minus 8, and then you would do 18 minus 8. Now, I've been trying to get through to you that solving an equation is the process of reversing your steps. So if I were to take this equation here, I need to reverse these steps. Not just reverse, but do everything in reverse. That means undo everything that was done at the beginning. So when you reverse your steps, you undo number 2 before you undo number 1. So what's my reversal here? The first thing that I would do to undo a subtraction is to do an addition. Then after that is done, I'm reversing my steps now. To undo multiplication, I would divide. Watch how we solve the equation. So the first thing that I want to do is take out the minus 8. I'm going to add 8 to both sides of the equation. Remember, keep this handy. I'm undoing this, or the order of operations, in order to come back to what will inevitably be the answer, the number 6. So I add 8 to both sides, and I'm left with 3x equals 18. So I undid the subtraction. Next, I'm going to undo the multiplication. So remember, there's a dot there between the 3 and the x. So I'm going to divide by 3, and I'll get x equals 6. So solving an equation is to go in reverse and undo everything that was done. Let's look at now let's do a series of equations, and I'll try to remind you of this every single time I do one. So for my next problem, we have solve 4x plus 5 equals negative 11. So now I have two things going on the left side. I have multiplication and I have addition. So if I want to reverse things, I'll first want to undo the addition. So I will subtract 5. Write down the next. Don't try to skip steps. The more you write, the better you will do. I will get 4x equals negative 16. So there was step 1, undoing the addition. Next, I'm going to undo the multiplication. Now I'm going to divide by 4. So my x will equal negative 4. So undo everything, but go in reverse. I guess I should say you're undoing the order of operations in reverse, if that makes sense. Let's look at another one. Here I have solve 1 minus 2x equals negative 5. First thing I want to do is take the 1 out of there, because you have the minus. See, this is a little bit different than the other ones. If I were to go over here and rewrite the left side like this, it's easier for me to say, well, subtract 1 first and then divide by negative 2. But it's not so evident over here on the left when I'm doing this thing. I am going to subtract 1 first. And that leaves me with negative 2x equals negative 6. And then to finish it off, I will use division to take out the negative 2 that's attached to the x. So we end up with x equals 3. Now remember, to check yourself on these, to make sure you're doing them right, you would go and take the 1 minus 2x equals negative 5, and you would replace x with 3. And then once you get to the point where it's obvious that what you've done is correct, you go ahead and put a check mark so that you've checked it to make sure you did all the steps correctly. Now, as with last time, I'm just going to start throwing up equations and doing them. So I think if I just give you an equation, you'll know what you're supposed to do. So here I have negative 7 plus 11x, and that's equal to 15. Now to take out the negative 7, I want to add 7. And that leaves me with 22 equals 11x. To get the x, divide by 11. And we end up with 2 is equal to x. Now let's complicate things. Well, actually, I got one more before I complicate things, so I didn't mean to get you too excited about this next one just yet. Next I have negative 12 equals 23 minus x. All right, let me take out, remember you're trying to get x, I should mention, I didn't mention it so far, but the ultimate goal is to isolate the letter x on either side of the equation. So as long as it's by itself, you'll know its value. So with that in mind, I want to take the 23 out of the right side of the equation. Don't forget to line up your equal signs. Well, what's left though is not x, but negative x. And on the left side, we get negative 35. Now to get x by itself, because this is not done yet. I am not done until I get x. Negative x is not good enough. So the only way to get, well, there's a couple ways to get rid of the negative, but the easiest way probably is to divide by negative 1. That way on the right side, a negative divided by a negative cancel, and you'll be left with just x. And on the left side, you'll end up with 35. Now I'm ready to complicate things. Next, let's try 4w plus 15 equals 10w minus 21. Now, this is a little more complicated. What we want to do here is, I think the way we want to do this is, let's go back to a couple of examples. That example's fine. This example's fine. If the problem were like one of these, I would now know how to do it, but I don't know. So what you want to do to make it like that is to try to get the letters, the W, only to appear on one side of the equation. So I have to choose, do I want W's only to be on the left side, or do I want W's only to appear on the right side? You have to make this choice. That's one of the things that makes solving equations difficult, is I can't give you just one way of doing them. There's always multiple ways of doing these problems. Personally, what I would do is this. I would subtract 4w from both sides of the equation. I'll do this, I'll do this the other way when this problem is done. So what will happen then is I will get 15 is equal to 6w minus 21. The reason I subtracted the 4w was so that I wouldn't have to deal with a negative number in front of w. You'll see when I redo this example. Now, this is like the problems we have just done. So that's good. We know how to do this now. I will add 21 to both sides of the equation, and I get 36 equals 6w. And to finish it off, I will divide by 6. Now let me do the same exact problem again, but my first step will be different. So we're going to redo the last example. And that was 4w plus 15 equals 10w minus 21. Suppose I decided to get my w's to appear on the other side. What I could have done instead was to subtract 10w. That way the w's will disappear from the right and only appear on the left. So the right side is just negative 21, that's all that's left. On the left-hand side, I have negative 6w plus 15. Once again, this is just like the problems we did before these examples. In order to finish this off, I'm going to subtract 15 from both sides. So on the right, I get negative 36, and on the left, I get negative 6w. Now I want to get w by itself. That's negative 6 times w, so I want to divide by negative 6. That way these cancel all the way, and we end up with w equals 6. The point I'm making is that this answer and the previous answer are both right. It does not matter what letter it appears on. If it's on the right, what side the letter appears on, whether it's on the right or the left, it's irrelevant. But you need to make a decision on what side you want it to appear on. And I believe that you should do that very first when you're getting equations. Try to figure out what side it would be best to have the letter on. Let's do another example. So as we move, the examples will get more complicated, but the steps, no individual step will be more difficult, but the problems will become more complicated. So look at this one here. I have 23c plus 20 equals 29c plus 74. So I have to decide what side I want c to appear on. Well, let me come back to this last one for a second. When I subtracted the 10w's, I had a negative 6w, and just personally, I would prefer to work these problems without a negative in front of the w if I had the choice. Well, I do have the choice. Look at this one here. If I thought about subtracting 23c from both sides of the equation, I would have a positive 6c on the right side, which to me is good. I like that. However, if I subtracted 29c from both sides, I would have a negative 6c on the left, and that's not as good, although it's not that big of a deal. I would just prefer to not have to deal with the negative if I didn't have to. So I'm going to subtract 23c from both sides. This is simply my preference. You do not have to do that. On the left, all I have left is a 20, and on the right, I have I have 6c plus 74. So I'll subtract 74 from both sides. And that leaves me with 6c equals negative 54. And then to finish this off, I will divide by 6. So I get negative 9 equals c. We're almost at the situation where I can give you a complete rundown on the steps you should do when you solve an equation. This one will help in that vein. Here I have negative 9y minus 4 plus 6y equals 2y plus 36. Now notice this is more complicated than the previous examples. Not only do I have the letter appearing on both sides, but I have multiple occurrences of the letter on the left side. So the first thing you should always do is this. Simplify. So what I mean by that, here on the left-hand side, combine any like terms that you can. So on the left, I know I have a negative 9y and a positive 6y. So this left side can be simplified to get negative 3y minus 4 equals 2y plus 36. And so now this does look like the previous problems. All I had to do was do a little simplifying first, and now they do look like that. So I have a y on each side, so I want to determine what side I want the y to appear on. And again, it looks to me like it's slightly advantageous to choose the right side to have y, because I'll be avoiding negatives. So I'm going to add 3y to the left and add 3y to the right. So to the left we have negative 4, and on the right we have 5y plus 36. Then I'll subtract 36 from both sides. And it looks like negative 40 equals 5y. And last I will divide by 5. And I have negative 8 is equal to y. So let's do a rundown of what I've done here for this last example, and I'll write them down. So the first step is to simplify each side of the equation. That means combine like terms, use any kind of properties like the distributive property or anything like that, and collect like terms before you do anything else. Second thing, get the letter to one side of the equation. So that should always be the thing you do next. Pick the side that you want the letter on. Then, of course, if you've got the letters on one side, you want to get the numbers on the opposite side. So get the letters on one side, get the numbers on the opposite side, and then finish off the equation. Usually it's easy. By the time you've done steps 1, 2, and 3, it's usually very simple to finish it off. So finish off the equation. Let's do an example where all of these steps come in handy. What I have then is 18 minus d plus 5d minus 11 equals 9d plus 19 minus 3d. So the first thing I want to do is simplify each side of the equation. On the left, I have 18 and negative 11. I can combine the two of those things to give me a 7. And then negative d plus 5d is positive 4d. And that's equal to the other side. The only like terms I have is 9d and negative 3d. So when I combine those, I'm going to get the 6d plus 19. So that takes care of step 1, or the first step where I simplify. Second step, decide what side you want the letter to appear on. And once again, I find it a little bit advantageous to allow the letter to appear on the right side. So on the left, I'll have a 7, and on the right, I'll have a 2D plus 19. That takes care of step number 2. Now, step 3 is to get the numbers on the other side. So I'm going to subtract 19. Subtract 19. Now, it looks like I have negative 12 is equal to 2D. And then to get D by itself, I will divide by 2. So we'll have negative 6 is equal to D. Next example. Here I have 2B plus 7 minus 6B plus 12 is equal to 4B plus 5 minus 7B minus 1. And when I look over the left, I see that I have a 2B and a negative 6B, which I'll combine together to give me negative 4B. Next, we have 7 and 12, positive 7 and positive 12. I'll combine those together to give me plus 19. Moving on to the right, I see that I have 4B minus 7B. That'll give me negative 3B. And then finally, I have 5 minus 1 will give me positive 4. Let's see. It still seems advantageous to me to add 4B, to make it so that the B's occur on just one side of the equation. So we get 19 equals B plus 4. Subtract 4. And it looks like we get B equals 15. Next, I have negative 11 plus m equals 3 times 2m minus 1 minus 4m. So before you do anything about moving stuff around, remember the steps. The very first step that you want to do is simplify each side of the equation. On the left side of the equation, there's nothing to do. I cannot combine any like terms. The right side, though, is not so. I have to use the distributive property to break out of the parentheses first, and that will give me 6m minus 3. And I have a minus 4m that was just sitting there. Now I can finish off the simplifying by combining the 6m with the negative 4m, and I have 2m minus 3 on the right and negative 11 plus m on the left. And just for variety, even though I think it's easier to go to the right side, they seem like they all go to the right side as far as getting the letters over there. So just for variety, I'm going to go and get the letters on the left side this time. So I'm going to subtract 2m from both sides of the equation. And I have negative 11 minus m equals negative 3. Now then I will add 11 because I want to get the numbers to the other side. Don't forget there's a negative in front of the m. Now had I gone originally and gotten the letters to the right side, I wouldn't have to do any more steps. I would be done. But since I chose to go to the left this time, watch what I need to do. I need to divide by negative 1 because having a negative in front of it's not good enough. and it looks like we're going to get m equals -8. Here, let's do a somewhat heavy example for my next one. Here I have 1 plus 5 times 4a minus 7 equals 4 times 7a minus 3 minus 30. So let me see, obviously distribute before you do anything else. Don't forget to write your equals down. Keep your equals lined up. That's really important. I will multiply this 5 through these parentheses there. The 1 I will bring down. When I do this, let's see, 5 times 4a is 20a. And then 5 times -7 is -35. And then I'll do the same thing to the right. 4 times 7a is 28a. And then 4 times -3 is -12. Not a lot of simplifying to go on after this. On the left-hand side, I have a positive 1 and a -35. So I have -34 plus 20a. And on the right, I can combine the -12 and -30. That gives me 28a minus 42. I will subtract 20a. Once again, I see being on the right is a little bit advantageous to me. So on the right-hand side, I'll get an 8a minus 42, and on the left side, I'll get -34. Let's see, I'll add 42 to both sides of the equation. And it looks like I will get an 8 on the right and an 8a on, an 8 on the left and an 8a on the right. So I will divide by 8, and I will divide by 8. And that will give me a equals 1. So as you can see, the problems get more complicated, but no individual step is more difficult than it was before. Look at this next one. It looks horrible when you first look at it, but if you stick to the plan, it all comes together in the end. So here we have -3 times 4c plus 9 plus 2 times 3c plus 8. That equals -c plus 2 times c plus 5. A lot of distributing that I have to do here. So I'm going to take the -3 and multiply it through these parentheses and get -12c minus 27. Then I'll do the same with this 2. I'll get 6c plus 16. Bring down that -c. And the last distributing I have to do is the 2 through those last parentheses. There, I will get 2c plus 10. Now let me do my simplifying. On the left, I have a -12c, but I have a positive 6c. So that gives me -6c. I also have -27 plus 16, so that will be -11. On the right, the only things I need to combine are the c's. -c plus 2c is c, and then I'll bring down the positive 10. Once again, it's easier to go to the right with the letters. I'll get 7c. Don't change the variable, or actually it's not a variable, it's an unknown quantity. 7c plus 10. And on the left I have -11. Let me subtract 10. So on the left, I'll get negative 21, and on the right, I will get 7c. And then I will divide by 7. To get negative 3 is equal to c. Now, what we're going to try to do with all this equation solving, the point of equations is to actually solve problems. And most problems that you encounter will involve words, typical English words, and you have to take those words and turn them into math. In your textbook, we'll have a list of these, but I'll try to tell you the list. I'll try to add to the list as we go on. So this is just a little sampling of some of the words and what their meanings are mathematically. So let's start. A simple one is this. The word sum, and everybody knows that means addition. And then the word difference is subtraction. But there's some other ones that you may not know. Increased by means addition. Decreased by means subtraction. There's more for addition and subtraction, but I'll go over those as we go through the problems. Then we have words like this, product, and that is multiplication. And then I have quotient. That's division. And then the easiest one of all, the word is simply means equals. So what we try to do is to get you to have a chance at solving these word problems. We're going to approach it slowly by trying to get you to convert phrases, or actually sentences, convert them into an equation. So I'll show you what I mean. Here's the first example. We have 12 more than a number is 31. So notice this is a sentence. It has a verb, subject, everything's in there that you need. Let's convert this to an equation. What I do with these, if there exists one, look for the word is, because underneath the word is, we can put the equals. And now you can read, on the left side of the is the left side of the equation, and on the right side of the is the right side of the equation. So in this case, I have a 31 on the right, and that finishes off the right side because nothing comes after the 31. On the left side of the equation, we have 12 more than, and you can use any letter you want for the part that says a number, but I'll just choose X, and I'll just use that all the time. So I am going to solve this then, I'm going to subtract 12 from each side of the equation, and I will get X is equal to 19. So that's the game plan. I give you a phrase, well actually a sentence, and you convert it to an equation and solve it. Let's try another one. This one goes 14 less than a number is 19. And this one's very similar to the previous one. I'll put an equals under is, and I will convert the numbers wherever I see them. Now, I actually made a mistake on the left-hand side, but that's the less than. Less than is subtraction. This is wrong. Unfortunately, the correct way to write the left side is x minus 14 equals 19. When I mean 14 less than a number, I mean to take away 14 from that number, so that what results is a number whose value is 14 less than it was before. So keep this in mind. This causes students all sorts of issues. This does not appear, the left-hand side does not appear in word-to-word order as the equation does. Although the is still appears with an equals, that note will never budge. And you can guarantee this, whatever's on the left of the is the left side of the equation. Whatever's on the right of is the right side of the equation. It's just the left side or the right side may need you to do some converting to get it to work out mathematically. Of course, once you get the equation, and that's the thing about word problems, is most people say that if I can get the equation, the problem's not hard. Well, that's exactly what makes the word problems difficult, is getting the equation to solve. I'm going to add 14 to both sides of this equation, and I'll get x is equal to 33. Next, I have 11 more than twice a number is 5. So let me get my is in there. Once again, the right side is simple. The left side is pretty simple. Most of the time you can read this in direct order. So I can bring down the 11. More than, the more than is an addition sign. That more than is for the addition. That means plus. And then twice a number, that part right there, is 2 times x. I'm still using x for my unknown number. To solve this then, I'll subtract 11. And I'll end up with 2x equals negative 6. And then to get x, divide by 2. And I'll get x equals negative 3. Let's see. Next one is 13 subtracted from 3 times a number is negative 1. So once again, this is a situation where the left side is not going to work out quite as easily as I would like. You have 13 subtracted from. Subtracted from, that part does mean minus, except you're going to have to reverse things a little bit and put the 3x before the minus and the 13 after the minus. And then, of course, to solve this, I'll go ahead and add 13 to both sides. And I will get 3x is equal to 12. And then I'll divide by 3. And I'll get x is equal to 4. Next, we have 6 times a number is the same as 5 more than 7 times the number. So I'm going to find the is in this. In fact, this whole thing right here is the equals. Is the same as does mean equals. So let me go ahead and do that. Now, the left side, 6 times a number is on the left. So this chunk right here, this 6 times a number, I can call 6x. Now, the right-hand side, since it goes around like that, I can't circle and do a nice thing like that. But I have 5 more than, so 5 more than 7 times the number, 7x. I think it's best in this case, even though I'm going to have a negative x, it's going to take me less time to solve this if I subtract 7x from each side. So I'll get negative x is equal to 5, and then I will divide by negative 1 and get x equals negative 5. So these are the same, follow the same kind of principle. They get more complicated and cumbersome as you go along. Let's do the next one here and see what happens. Here we have the sum of 11 and triple a number is the same as 5 less than 5 times the number. So let's see what we have here. So there it is the same as, there's my equals. Let's get it in place. Now to the left of that, I have the sum. So I know there's addition, the sum of 11 and triple a number. So we have the sum of 11 and triple a number. Triple is 3 times, of course. Is the same as, and the other side I got 5 less than, remember that's going to be minus 5. 5 less than 5 times the number. So that's a 5x there. Here I see no advantage to going and getting the x on the left, so I will go ahead and subtract 3x. You get 2x minus 5 equals 11. Next I will add 5. I'll get 2x equals 16. And then finally I will divide by 2 and get x equals 8. Finish this out, I want to give you an equation and you convert it to a sentence. So we're going to convert x plus 6 equals 15 to words. So how can we say this x plus 6? Well, we can say the sum of a number and 6 is 15. So it's pretty simple. Once you're given the equation, it's pretty easy to come up with the phrase. I'll put quotes around it so you know that that's the answer to the problem, is the sentence. Let's do another example. Let's convert negative 9x equals 10 plus x to words. So in this case, we can say, for the left, the easiest way to say this is probably negative 9 times a number. So we'll have negative 9 times a number is, it's hard for me just to say is, I guess we could say is the sum of 10 and that number. And by the way, if you have an equal sign, then the phrase that you get is actually actually a sentence. So you need to put a period at the end of it.